Right, for question 8a, you're told to show that AE is 22.6 cm. So the information given to us is that it has a square base, sides 15 and 15. Then it has a vertical height of 20. So this is point E. Now from the center over here, let's call this point M. Okay, in order to find the length of AE, we'll need to be able to draw right angle triangles. So in this case, the relevant right angle triangle will look like this. Okay, so let me extract this triangle out. It will look like what I have on the screen right now. It's being point M, E, and A. So this is what we want to find out. We know that this is 20 cm. Okay, so in order to find AE, I must be able to find AM. What? No, AM, M is the midpoint. M is not 7.5 as well. AM is also not 7.5. So if you are telling me that AM is 7.5, it means that you did not get this question correct. Square root 15 over 2 square plus 15 over 2 square. Okay, because M is the midpoint. If I extract the triangle, if I look at the top view, this being A, B, C and D, B, C and D. This is the top view, so this point M. This is 15, this must be 15 over 2. And this is my right angle triangle. So this is also 15 over 2. Okay? So this is how we get AM. So for Sophia, this is what we have, A, B and M. 15 over 2, 15 over 2. Get it? So once we get AM, we will be able to get our value of AE using Pythagoras theorem again. Hey, part B, anybody needs help? B? None. Part C. Then I'll move on to part D. Part D, we have a part of the pyramid left after it is cut. So this being my original pyramid has a height of 20. So after I cut, I get a smaller pyramid. Then I have a base left, right? So this is equal to this one plus this. Yes? Agree? Sophia, okay? Now what is the height of this base? 4 cm. So what must be the height of this pyramid? 16 cm. Out of these three figures shown on the screen, which of them are similar solids? The two pyramids, right? Okay. And now I'm going to highlight this area that they want us to find, and which is known as TQRS. Isn't this the same as this square over here? Same, right? Must be the same square lah. So if I want to find this area, they want the top of this base, right? Because these two, when you add them up, you get this triangle, yes? This pyramid, yes? So they must be a perfect fit. They are the same area, the two yellow color one. Okay so far? Alright? Now, since they are similar solids, let us consider the ratio of green to yellow. What is the ratio of the area for green to yellow? Ratio of area. let me put in some helping numbers. Here we got 15. Here we got 15. Then I do not know what this is. I do not know what this is. Is there a need to find out? So on and so forth. Okay. So now, what is the approach we should take? If there are similar solids, similar figures, what is the ratio of area given by? For similar objects, area 1 over area 2 equals to height or length lah. Length 1 over length 2. All agree with this? You must agree with this lah. Okay. So what is the ratio of any known length over here? You can tell me length, can tell me base, the breadth, height, slant height, anything that is measured in cm that you know. Do you have the ratio of any of these two things? What are they? Height. What is the ratio of height? 20 to 16. Can simplify further? Can. This will become 5, and this will become 4. Correct? So if I want the area, ratio of area, okay, so let's call this big lah. Big and small. So this must be big, and this must be small as well. So area big over area small must be equal to length that is big. So 5 over 4, and I square it, which is 25 over 16. Now out of these two things over here, which is the one I want to find? Which area? Big or small? I want to find the small one. So obviously I must have the big one, right? What is the bigger area? 15 times 15. Okay, so 15 times 15 over area small equals to 25 over 16. You must be able to do it by yourself now. Area small equals to whatever. Okay, and that's the answer. Can, Jolene? Is there any part you don't understand? Why 5 over 4? Okay. Do you understand this relationship over here? Okay, what is the length that is big divided by the smaller length? Length over here can refer to height, can refer to breadth, diagonal breadth, diagonal length, slant height, anything as long as measured in cm. So looking at the two similar solids, what can we compare? Vertical height. Okay, what is the bigger vertical height divided by smaller vertical height? 20 divided by? Yes, you are right. So 20 divided by 16, you get 5 over 4. Can? Okay. So this is it for question 8. And now question 9. Anybody needs help? For part A, part 1. A, part 1. Filling in the blanks. None, huh? Okay, now part 2. Calculate an estimate of the mean mass of each baby. Anybody needs help? Sure? Sophia, okay? Now part 3. Estimate of the standard deviation. Do you remember how to use your calculator for this? Okay, then I want the whole class to try now. Anybody not using Casio? Anybody not using Casio? If everybody is using Casio, then take out a calculator, turn it on right now. And in the table of values, I want you to make the following, placing the following information. 1, 2, 3, 4, 5. So this is 4, 11, 19, 12, and 4. 2.0 and blah, 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 blah. Mass, frequency. Okay, now in your table, in your question, I want you to include another row here. Include the row right now. Just use your pencil, don't need ruler, just draw it quickly. And put aside class mark. Okay, what do you think goes into the first blank? What do you think goes into the first blank? 2.25, okay. Who needs me to explain why it is 2.25? Raise your hand now. Okay, you see, the mass over here is given as a range from 2 to 2.5, correct? Do you know how, out of these four, there are apparently four babies with a mass between 2 to 2.5. But are all four babies having the same masses? Don't have, we don't know. Could be all the same, could be all different, but we do know that they are between 2 to 2.5. So we are looking for the class mark, which is the center value, kind of like the median, but not exactly. So the center value of 2 and 2.5 is 2.25. So we need to put in all the other information, which in this case will be 2.75, 3.25, put them in right now, 3.75 and 4.25. Put in all this information. Now with this, we do not require the mass row anymore. So you can take a pencil, cancel it. We don't need that anymore. Because we cannot find standard deviation, we cannot find average using a range. We can only find an estimate using the class mark. And it is an estimate because I don't know the distribution. So it is just agak-agak. So in Singaporean terms, there are agak-agak 4 babies with mass of 2.25. Okay? Or rather, I should say there are 4 babies with an estimated mass of 2.25 kg. There are 19 babies with an estimated mass of 3.25 kg. Get it? Now, to find the standard deviation, calculator on, press mode. First row, second last button. Press mode. You should see 1, 2, 3, 4. What do you think we should be selecting? 2, stat, which refers to statistics, which is what we are doing over here. So press 2. Now we see options 1 to 8. Which one do we select? Which one do we select? 1. Refers to variance. Okay, but don't need to know. Just know you select 1. Okay. You should see a table like this that has 2 columns. It has X and frequency. If you only have 1 column, pass it to your friend, ask them how you make sure there are 2 columns, X and frequency. All have 2 columns. Look at your partner's calculator. Okay, before you go into your O level, your mid-year, your prelim, go and check, make sure you have 2 columns. Once you have 2 columns, you are safe. If you don't have, pass it to your friend, ask them how you do. Or learn how to make it appear yourself. What do you think goes into the X? Is it the class mark or the frequency? Class mark. Okay, press now. 2.25 equals. Then what do you see? And the frequency? No, in your calculator, what does it say? It says 1, isn't it? Never mind, just continue to fill in all the X values first. So 2.75 and equal 3.25 equal 3.75 equal 4.25 equal. Okay, right now stop first. Do you see row number 6 appearing? And there's nothing inside because you haven't keyed anything yet, right? Ignore it. Press right, go up all the way, or press right and down. Right and down. You will head back to frequency row number 1. Am I right? Is that what all of you see right now? Frequency row number 1. What do you think we should key into a frequency? 4. So 4 equal. Next, 11 equal. 19 equals. 12 equals. 4 equals. Right now, your calculator should be on the 6th row, but the 6th row is empty. Do you all have that? Check your partner's calculator. Do you all have that? Because if you don't, then it's going to be wrong. Okay, so because you have pressed equal, you move on to row number 6. All the data is stored in right now. It's in ready. Go and press on. Press on. You see, the table disappears and you are left with a 0. Correct? You are now in the statistics mode. Don't be so uncomfortable with that 0. Doesn't matter. Okay, all the data is inside already. Now I need the formula for my standard deviation, which is available at your front of your TYS. It is also provided to you. So write down standard deviation equals to square root summation fx squared divided by summation f minus summation fx divided by summation f squared. Okay? Copy this down. Put on the equal. Now, this is the part where we must substitute in values. You are not allowed to just from here give me answer. Even if it is correct, you'll not get a mark. Okay, you must show substitution. So the substitution, first one, we are going to find out what is this summation fx squared. Okay, so from your calculator, press shift and press 1. You see shift 1? In the yellow color words above 1, it says stat again, right? That is what we require. So shift 1 will bring you to a menu that has options 1 to 6. Okay, what to choose? What are we looking for over here? Summation fx squared. So sum, yes. Select 3 for sum.
Yes.
Okay, now you have two options. Summation x squared or summation x. What do you think you should select? Summation x squared. Okay, so press 1. So on your calculator, you should see summation x squared with a 0. Press equal. A number appears. That number is, what is it that you see? 545.125. That is our summation fx squared. Although our calculator calls it summation x squared, our formula says summation fx squared, they are the same. Now in the denominator, it says summation f, right? So what do you think summation f stands for? Total frequency. So in this context, according to the question, what do you think the total frequency is? According to the graph, 50. Okay, we expect to put 50 inside. Now I just want to check whether my calculator data is correct. So So this is what you can do to make sure you have the correct number of data entries inside. Press shift 1. Okay, shift 1. Then you see your option 1 to 6 again. You press 4 for variance. Press 4. And then you see options 1 to 4 again. Number 1 is the number of data entries. Press 1 and equal. What do you see? 50. It tells us that we key in the correct amount of data. If you are confident you keyed it in correctly, you can straight from the question put down 50. If you are like me, kiasu want to check, yeah, this is how I'll check it. Okay so far? Or this is recorder, you can listen to the video again if you forget. Now minus, open bracket. Where is my summation fx? Press your on button again. Shift stat. Which option should we choose? 3, yes. And after that, 2. What do you see in your calculator? 1, 6, 3. Divided by summation f again, 50. Close bracket, square root everything. Now this one, you don't need your statistics mode already, but you can still use it. 163 divided by 50. I square it. Then I take 545.1125 divided by 50 minus answer, square root the answer, I get 0.52431. 5 SF, rounded off to become 0.524. This is the answer for the standard deviation. Any questions? Then do you know how to check your answer? Your calculator can do so many things, right? Surely it can, with a few buttons, give you a standard deviation. There's a way for you to check your answer. What? 163050 RY? This is the average actually. So it's the square of the average. Okay? Now, to check your answer, you go to, you press the on button again. So this is a way for you to check. Shift 1. You go back to a stat again. Then you press 4 for the variance. And we are almost there already. You see option number 3. You see this symbol? This is our answer. Press 3 equal. Do you get the same thing? Same thing? Okay, so this is how we check. Can? Yes? Yeah, we can do all this in exam. No need. Whatever is in your answer key, right? All the addition, square, everything, no need to write. Because our answer key is not that accurate. I mean, it's not the best. Some steps are redundant. And I'll tell you if they are. That is 1 mark only. But I need to see substitution over here. Greater than 2.8. I would like to change that to less than or equal to. You get what I'm trying to say? Okay? So all these should be in your mind, but I'll just write it down for you to follow. So it says that 90% have masses greater than 2.8 kg. This implies that they are trying to say 10% have masses less than or equals to 2.8 kg. This is what they are trying to say, and this is what we are trying to prove whether it is right or wrong. So let us go back to our graph. Look for 2.8 kg. How many babies have masses 2.8 kg or less? From graph, 2.8 kg and less, 6, 7, 8, we have 9. 9 babies have masses less than or equal to 2.8 kg. Okay? So 9 babies refers to how many percent? Since there are 50 babies, 9 babies must refer to how many? 80? 1 8? Yes, you're right. So 18% have masses less than or equal to 2.8 kg. So does this tally with the original statement? It says that 90% have masses greater than 2.8. So they are trying to say that 10% have masses less than or equal to 2.8. Is that true? No, it is not true. In fact, 18% have masses less than or equal to 2.8 kg. Okay? So therefore, the statement is not true. Part B. For probability, part 1, anybody needs me to go through? Part 1? If not, part 2, anybody? Okay, part 2. Okay, now part 2, find the probability that they both have a baby girl. So from our chart, this is under 30, greater than or equal to 30, boy, girl. 3, 7, 9, and 6. For both of them to have a baby girl, the first woman must have a baby girl, right? Does it matter what her age is? No, it doesn't matter. So how many women have a baby girl? How many women have baby girl? What plus what? 7 plus 6, which is 13. Divided by what's the total? 25. Okay, this is the first woman. She has a baby girl. Now after I remove this woman, because I've already selected her, I cannot select her again, right? How many of such women are there left? 24? Of such women who have a baby girl? 12. So 12 out of how many were left? 24. This gives me 13 over 50. This is the probability of selecting 2 women, both have girls. Okay? Next part, part B. Probability that they are both aged 30 and over, and only one girl, or only one baby boy. This table over here is very useful for us to answer this question. You can see it's only 2 marks. It does not require a lot of effort. Where are the cells? Over here I've got 3, 9, 7 and 6. Which one is relevant to us for women both aged 30 and over? Aged 30 and over. Which are the numbers that represent 30 and over? 9 and 6. Okay, which one is relevant to baby boy? 9. Okay. You see there are 2 women, right? The first condition is that first one must be over 30. Second one must be over 30. Let's write down the probability of that first. Probability both 30. Okay, let me just highlight. Both are over 30. So this one and this one, right? Only one can have a baby boy. So it must be this one, and if I select the first woman more than 30 and has a baby boy, then the second woman must be more than 30, have a girl, right? Because you only can have boy or girl, you cannot have anything else. So the other woman must have which number related to her? Which number is assigned to the other woman? 6. Over here. First woman, there are 9 such women for the first case. 30 and above have a boy. There are 6 women who are 30 and above and have a girl. Okay, this is the first case. I require these 2. So I'll multiply them together. So probability, first woman more than or equal to 30 have boy, and second woman more than or equal to 30 have girl. Okay, what is this probability? Start with the first one. Over 30 and have a boy. So that would be 9 over total number of women will be 50. Is it 50? Who told me 50? Or 15? It is out of all the women because all of them can be selected. So total how many women? 25. Okay, 3 plus 7 plus 9 plus 6. I am now looking at this case only. The first woman more than or equal to 30 years old have a boy. How many such women are there? No, how many women are more than or equal to 30 years old and have a boy? What do you say? More than or equal to 30 years old have a boy. How many? How do you get 10? Oh, 9. Okay, 9. So there are 9 such women out of a total of 25. Okay, so this one done already. So there is an N. N refers to multiply. Now I require second woman more than or equal to 30 years old but have a girl. So how many of such women are there? 6. Okay, so 6 out of 24. Are we done? No, we're not. Because the first woman can have a girl, second woman can have a boy, right? Right? So this is only half of the story. You see, I say the first woman is have a boy, second woman have a girl, but it can be the other way around, right? Okay, so let me just work out what this is first. 9 divided by 25 times 6 divided by 24. So 0.09. Okay. Now, the other case is that probability first woman more than or equal to 30 and have a girl. And second woman more than or equal to 30 have boy. So this will give us have a girl, right? So 6 out of 25 multiplied by 9 out of 24. And we get the same value, 0.09 again, because it is mathematically the same. So I can have the first case or the second case. We add them up. And our final answer will therefore be probability answer 0.09 times 2, 0.18. Okay? This over here is the long-winded approach, which I feel is the clearest for you. With enough practice, you don't have to do all this. With enough practice, you will tell me straight away that in red color, answer equals to, there are two cases, can be boy, girl, girl, boy, 2 times. First case, woman more than 30 years old with a boy, 9 over 25. Second woman, more than 30 years old, have a girl, multiply by 6 over 24. Answer 0.18. Can be in red. Don't need to write so much. But if you copy this down as your answer, I guarantee you when you go back and do your revision, you don't know why. You don't know why it's like that. Then it doesn't help. And this is what our textbook, our answer key gives us. If you just copy this, I don't think you understand. And the last question. Question 10. Anybody needs help? Part A, anybody? Okay, work out the mass of the box where she cuts a square side 5 cm from each corner. We originally have a cardboard box. This is 30 cm and this is 20 cm. The mass of the cardboard box is directly proportional to the area of the cardboard box. The greater the area, the more the mass. Obviously, right? And they gave us the relationship. 1 square meter has mass of 210 grams. 210 grams. Okay? So when I cut out a square of side 5 cm from each corner, take out 5 cm, 5 cm, take out 5 cm and 5 cm, 5 and 5. Do you expect it to be lighter? Obviously lah. Do you think we need to find the area? Yes, because the mass is proportional to the area. Now figure out what is this area after we cut out these 4 squares. 20 times 30, then minus 4 times of 5 times 5, and we get 600 minus 100, 500 square cm. Okay, so far? Now is 500 square cm bigger or smaller than 1 square meter? Now I give you another question. Is 500 square cm greater or less than 1 square meter? Who thinks it's less? Raise your hand. Who thinks it's more? Raise your hand. So judging from the response, some of you still don't know. How much is 1 square meter? 1 square meter in square centimeter. How much is it?
100.
It is not 100. It's 100 square. Because it is 100 cm multiplied by 100 cm to give you 1 meter times 1 meter, isn't it? And that's how we get 100 square and square centimeters, which is 10,000 square centimeters. So 500 square centimeters is less. If 10,000 square centimeters has a mass of 210 grams, 500 square centimeters must have a mass for 500 square centimeters must be equal to 210 divided by 10,000 times 500 to give us 10.5 grams. Do you understand the area? Do you understand also that 10,000 square centimeters has mass of 210 grams? Do you understand this part?
The 1 square meter is small.
1 square meter is quite big. 1 meter by 1 meter. One square meter equals to 1 meter over here and 1 meter over here. Right?
That is 210.
This one over here has a mass 210 grams. Okay, so this is 100 cm, 100 cm. So 10,000 square centimeters has a mass of 210 grams. Now I don't need 10,000 square centimeters. I only require 500 square centimeters. So mass equals to 210 over 10,000 times 500. You get 10.5. So that's part A. Part B. Can you visualize folding this cardboard into a box? Can visualize? Basically, right, you dot this side, you dot this side, dot here, and dot here. Then you fold along the dotted line to get a box. Can visualize. What is the base area of this box? Equals to? She cuts out a side square side x. So instead of 5, it is now x. Because the question updated already. Now she cut out side x. So what is the base area of this box?
30 minus x.
Are you sure minus x?
30 minus x minus x.
Okay, 30 minus 2x times.
20 minus 2x.
Okay, this is the base area. What is the height of this box? X. Height equals to x. So volume equals to base times height. X, 30 minus 2x, 20 minus 2x. And that's shown. Explain, prove, same. So the explanation is over here. You must show that base area is as such, height is as such, then you multiply them together. You can even go one step further to talk about, oh, the base is, the breadth is actually 20 minus 2x. The length is 30 minus 2x. So multiply them all together. Okay, here I skip one step. And really it's 1 mark only. Can? Now explain why x is greater than 0 but less than 10. If we have a box, can the height of the box be 0? Cannot. So based on the height must be more than 0 lah, right? Therefore x is more than 0. That's the first thing that we have. Okay? Next, the breadth must be more than 0 also. 20 minus 2x must be more than 0. And 30 minus 2x also must be more than 0. All these things must be more than 0. So from the first one we have 2x is less than 20. X is less than 10. And 2x less than 30, x less than 15. We are solving these two at the same time, simultaneously, we should have learned. So what is the value for x? What is the range for x? If x has to be less than 10, it has to be less than 15. Ultimately, x is less than 10. You can do it mentally or you can draw it out. This is 10, this is 15. I've got x is less than 10, x less than 15. Where they intersect must be my answer. So x is less than 10. At the same time, it is greater than 0. So this is how we get B part 2. Part C. Look at the number of marks. 7 marks. Never seen 7 marks for one question before. It's gonna be x lah. Your horizontal axis is our x-axis. So obviously you must have a vertical axis. Considering that we want to we have a limitation to the volume. We have a limitation to the area. Your job now is to decide, do you want the vertical axis to be volume or area? Volume or area? If we choose volume, can you plot a graph of volume against x? Can you? Do you have an equation for volume relating to x? So V equals to x multiplied by 20 minus 2x multiplied by 30 minus 2x. Do we have the equation? Yes, we have. So can you plot? You can plot. Yeah, it's going to be cubic. It is going to look like this. Everybody knows how to plot a graph. You will get something like this. It is not a parabola. Okay? So this is our, after you plot in everything, this is our graph. Volume equals to x, 20 minus 2x, 30 minus 2x. I give you some figures over here. This is 1200, about this part is 1800, so on and so forth. Which point are we interested in based on the question? Which volume are we interested in? Because this tells us as x increases from 0 all the way to this side, we see the volume will increase. Then it reaches a maximum volume, then it drops again. If x is equal to 0, visualize what the box looks like. If x is equal to 0. Is there a box? If x is 0, is there a box? No, it is a flat piece of cardboard. What's the volume? 0. Now when your x starts to increase, when you cut out a tiny little square at the 4 corners, you can fold a box already, right? But it is quite a wide box with a very small height, correct? So the volume is small. When the square gets bigger and bigger, the height increases, but the area gets smaller. However, it works out that the area starts to increase. There will come a point in time when your square that you cut out is so big that the area is so small, overall the volume starts to drop. Okay, and it will start to drop until this value 10. When x is equal to 10, what does your cardboard look like? When x is equal to 10. This is x equal to 10. Okay, you cut out this square, you cut out this square, 10 by 10. You're left with a flat piece of cardboard again. Volume is 0 now. Get it? Okay, so this is why our graph looks like this. So out of all this information, we are only interested in one volume. What is that volume? 900. So from our graph, we search for 900, which is over here. Draw a dotted line across. This is volume equals to 900. If we have a graph, if we have two graphs, we are always interested in finding the intersection points. Meaning over here, this value and this value. Okay, from our graph, they are 2.3 as well as 5.7. What does this mean to us? When x is equal to 2.3, you must be able to interpret. When x equals to 2.3, he's cutting off 4 squares with side 2.3 by 2.3, right? So what is the volume of the box after you cut off these 4 squares? 900. Very good. What is the volume after you cut off squares of 5.7? Also 900, right? Now, what about in between? What is the volume of the box? Anywhere between 2.3 and 5.7. More than 900. So, can we accept those values as well? Yes. So, I am only interested in this region. Or this part, not interested. Because the volume is less than 900, which doesn't correspond to the requirements. They require more than 900. So I only can consider the yellow color part. That means my x can range from 2.3 until 5.7. Anywhere in between is correct. However, there is another stipulation. There is another condition. What is the other condition? What is the other condition that they have? Smallest what? Smallest mass. Now, all these are between 2.3 and 5.7 will meet the requirement of 900 square centimeters minimum. But if I want it to be the lightest, can you use your logic and tell me what is the value of x that will result in the smallest mass? Is it 2.3 or 5.7? Cannot be both. 2.3 will result in a box with 900 square centimeters, but different total area, so different total mass. 5.7 will result in a box also 900 square centimeters, but different mass. So which one will give us the smallest mass? Why 2.3? Smaller area. So you are saying that you cut out a smaller area, you will result in a smaller mass? Really? So think, all of you are able to think this. The process right now is that I'm going to cut out 4 squares. I can choose to cut out 2.3 by 2.3 or 5.7 by 5.7. They will both result in 900 square meters. But one option that I cut out will result in a smaller mass. If you want smaller mass, you want to cut more, you want to cut less. I want small mass, so you want to cut out a lot or you want to cut out a little bit? Cut out as much as you can, right? This one needed. Needed. All taken already? I haven't taken yet. Anybody has a piece of rough paper to spare? What? Oh, okay. So this is the original cardboard. I can choose to cut 2.3 by 2.3 like this, all around. Okay, then I fold, I will get a volume of 900. Okay, then you go and fold, and fold. Okay, I get a box, volume 900. Alternatively, this 2.3, I'm going to now cut out 5.7. Bigger, right? And then I fold again. Uma, can you pass me that box? Thank you. Okay, now, both of these boxes, they have a volume of 900 square meters. Which one weighs less? This one or this one? Why this one? Because I tear out more, right? So which is the answer? 2.3 or 5.7? 5.7. So we cut out the square of side 5.7, then you will be able to find the area. With the area, you can find the mass again. Understand? Now, this is the standard for O level. Can you get A? Can get A or not? Yeah, for paper 1 and 2 combined lah.